Today's question is simply one 6 marker, and it comes from the old specification, 2014. However, it's really relevant for us because it covers those key basic principles of bonding and structure. So we've got explain why chlorine, Cl2, is a gas at room temperature, but sodium chloride is a solid at room temperature. When we see the word explain, again, I always talk about the Backstreet Boys, we need us to tell us why. So when we're looking at chlorine, we know that this apparently is a gas, and this here is a solid. So what this is really getting at is the different types of bonding. When I look here at chlorine on its own, Cl2, is a non-metal. So if I've just got non-metals, that means that we do covalent bonding. And indeed, this here, Cl2, is a simple covalent molecule. And covalent bonding, remember, is where we share electrons to get a full outer shell. If I look over here at sodium chloride, we've got a metal and a non-metal. So that means that we do ionic bonding. The one where we get that swap of electrons. Sodium got one too many, chlorine got one too few. We trade them off and we have a positive and negative ions. And indeed, you can see here that this structure here is called a giant ionic lattice. So the question is, how does this then relate to our boiling points and therefore being gas at room temperature or solid at room temperature? So simple covalent molecules are really weird because I have this strong covalent bond between here. That's really strong. However, if I take another chlorine molecule, let's say I'm just going to draw it here, whilst those lines, those bonds are really strong, in between we have really weak intermolecular forces. I'm going to write this really clearly. This is one of those key words, he says clearly and then he's snaked it up. This is one of those key words that shows the examiner you really know what's going on. We've got strong covalent bonds, but these weak intermolecular forces. And because they're weak, it doesn't take much energy to break them apart. So those molecules, you're not going to break up the chlorine atoms, but those chlorine Cl2 molecules are going to be easily broken apart. And that's why it is a gas at room temperature. If I look over here, between these positive and negative ions, we've got really strong electrostatic attractions. Electrostatic because they're charged and they don't move. And it's strong because that force between the positive and the negative is really strong. And it also, you're surrounding them. So you've got all of these kind of adding up. It's a really favourable arrangement. So that means to break them apart, that takes a lot of energy. Now I know that I've done an extensive amount of notes here, but that's mainly because I'm trying to show you that if you think about the background science, the writing it up becomes really formal. All I'm essentially now going to do is make this information, that thought process that I'm doing, into a written answer. So don't be afraid to take 2 sections. Don't be afraid to split up your ideas. Okay, a paragraph is simply a new idea. So I'm going to do 1 paragraph on chlorine and 1 paragraph on sodium chloride. I don't need to waffle. Chlorine does covalent bonding and forms simple covalent molecules. So we've explained our origin of the bonding. So let's now think about those properties. Although the covalent bonds are strong, there are these weak intermolecular forces between the molecules. So why is this relevant? Those weak intermolecular forces are easily broken and we've got a low boiling point. Now you'll notice that those are 3 quite clear, simple sentences. I know the language is tough because we're using lots of technical terms, but I haven't waffled. I've simply gone through our logical points and this is why it happens. So we're covering our explain. So now for the ionic substance. And we're going to follow the same procedure, a sentence and then an explain sentence and then an explain sentence. So sodium chloride has ionic bonding and forms a giant ionic lattice. That's our insight. So now let's explain those bonds. There are strong electrostatic attractions. These strong electrostatic attractions are between the ions in all directions. What does this mean? They require a lot of energy to break and is therefore a solid at room temperature. That means a high melting point and boiling point. And there we go. These types of bonding questions follow a formula and it just needs your revision. Assess what type of bonding goes on. Think about what structure it makes and therefore why the properties are the way they are. So you can see, although this is a 6-mark question and I've taken my sweet time with it, I've gone through everything quite logically.